Uh, Hello everyone. We are Group 11. My name is Musak Emerson, and I'm here to take you through the first part of the project. We are Group 11. Our project is titled Conversation Retrieval-Augmented AI Assistant for Breast Cancer Screening and Decision Support in Uganda. In Uganda, we are focusing on bridging the gap between advanced medical imaging and accessible local language clinical support. They go to the abstract, whereby here to have an integrated approach, whereby our research addresses a critical survival gap. We propose a novel framework that does not just analyze images, but explains them by integrating computer vision with retrieval-augmented generation. So we ground AI responses in a verified clinical guidelines. This assures that the assistant provides factually accurate, explainable, and then culturally relevant advice to both clinicians and then the patients. I dive into the introduction, whereby the crisis in Uganda is defined by late-stage diagnosis, whereby we face a systematic scarcity of radiocysts, meaning that most screenings happen too late. As you can know, that most of the hospitals in local areas, they have to transfer them to like referral hospitals in towns, which are in cities which are far. So there is an AI tool that are often black boxes that communicate only in English. So there is an urgent need for a tool that can assist in health worker in a rural clinic in a language they understand. For instance, let me say we use Uganda or actually, while maintaining global care clinical standards of the World Health Organization. We dive into the related works, whereby what they have implemented, their limitations, contributions, the key models they used. Majorly here I talk about, we had many, but talk about the rules at AI, pioneered the retrieval augmented generation framework to reduce AI hallucinations or false feedback by using external documents. So we had the Sunbird team provided the sort data set. Of course, this data set that we're going to also use as well, which is the gold standard for Ugandan multilingual NLP. However, as shown in our comparison table, no single study has yet unified the visual diagnostics with multilingual retrieval augmented generation for the Ugandan contexts. Talk about this research gap and then the synthesis, whereby this brings us to our identified gap, whereby the current state of the art models are solid, whereby they are either purely visual or purely textual, whereby they are almost exclusively in English, not being interpreted in our local languages. So the gap here is that there is no unified system that combines the pixel level analysis with the guideline grounded reasoning in local Ugandan languages. So our innovation here, we are developing a conversation retrieval augmented generation AI system that bridges this chasm, whereby it translates the complex visual activations into actionable medical advice in local languages, let me say Uganda, and then actually making the expert level screening accessible and then understood by all those people in local areas. I think that's what I have. Let me welcome my colleague.
Hello, my name is Apio Diane, and I'm going to continue where my colleague stopped, starting with the problem statement. So breast cancer care in Uganda is hindered by a limited number of specialists and diagnostic tools. The existing tools are mostly English-based or image-based, or they are text-focused, and they're not suitable for rural areas or areas where English is not widely spoken. And of course, now these systems have reduced trust by the users, and they fail to detect breast cancer early on. So when we look at our research objectives, we have 4 research objectives, and I'll be going through the first 3, and my colleague will take you through the last objective. So we have the knowledge-grounded retrieval pipeline. The first objective is to build a pipeline by collecting Uganda clinical guidelines alongside also World Health Organization guidelines and storing them in the FAISF. So this is to ensure that the responses are evidence-based and they are traceable and aligned with the already existing clinical standards in the real world. So in this objective, we want to increase trustworthiness of our system. Then in our objective 2, we want to develop a specialized language model that integrates image analysis with retrieved clinical guidelines. And using prompt engineering and fine-tuning as well, we propose that this system will deliver concise and safe clinical explanations and recommended steps to support effective interpretation of breast cancer screening results. And objective 3, the system will support English and alongside 4 local languages: Uganda, Acholi, Lukbar, and Runyankole. This is mainly to reduce communication barriers, especially in areas where English is not widely spoken, and improving how patients understand different information they will receive from the system, and also to ensure accessibility and usability across diverse communities in Uganda. Thank you.
Okay. Hello, it's Rotomio Jonathan. I'll be taking you through the next slides. Looking at objective 4, that's comprehensive multidimensional evaluation, majorly based on 4 categories to evaluate if this system is actually scientifically sound and really useful in real-life clinical settings. That's the diagnostic performance, factual consistency, utility and clarity, usability assessment. So the diagnostic performance ensures accuracy and precision based on those performance metrics, and then factual consistency ensures the correctness against the clinical guidelines. Then utility and clarity, then also usability assessment, where we'll have clinicians come in, use the system and give feedback on whether it was really helpful in decision making or it was giving understandable explanations. And moving on to the research scope and significance, we have first of all, in Uganda, breast cancer is the leading cause of cancer-related deaths in women. So this makes this research iconic in that focuses on a prototype AI assistant that helps breast cancer screening in Uganda, and it's also going to be made for use in rural areas and other places due to the conversational support in both English and local languages too, for understandability. It will measure based on 4 local languages. The major ones are Luganda, Lubara, Asholi, Runyankole. Yeah. And then there are also out of scope items. These were explicitly excluded due to feasibility issues like mammography and ultrasound that requires specialized equipment that is not included in the current scope. And also treatment recommendations. That system doesn't provide treatment recommendations, but rather screening only and planning, therapeutic planning. And then also the EMR integration, not at the moment, that's the medical record system. Also the clinical outcome trials. Maybe in future implementation phases, these will be implemented. Let's move on to the methodology. The methodology combines 3 major items. That's the ML for image classification, natural language processing for the AI assistant, the conversational explanations, and then the RAG, the Retrieval-Augmented generation for updated and trusted medical knowledge. Majorly that. So if we first do image input and data preparation. That's getting the breast cancer images and then feature extraction and all that. Then we train a deep learning classifier to help in distinguishing between benign and malignant cases. That's the cancerous and non-cancerous cases. Then the drug pipeline that gets the knowledge from information from the knowledge base and integrates it. Then we have the conversational AI assistant that will also have the multilingual support, and then the UI, the user interface, which will support image upload and validation, and then the conversational dialogue. Thank you.
Good evening. My name is Karenji Maria Duffin from Group 11, and these are our last 5 slides of our proposal, which is a breast cancer screening system. So we use 3 data sets, that is the language data set and 2 other image data sets. For the language data set, we use one from Sunbird that contains English and 6 Ugandan languages. For example, Acheso, Acholi, support the multilingual system. For example, Acholis can know, Lamis can know what the system is about, to ask a question. So it won't only constrain to English, but to also other languages to support the diversity of our economy in Uganda, which contains different ethnic groups. Then we also use a physical data set that has different categories, for example, redness, swelling, and other categories. So this basically shows what's on the surface of the breast. For example, is it red? Are there lumps on it? Then we also use the histopathology data set that contains two categories, which is malignant and benign. These are basically microscopic tissue images. Yeah, I'm going to talk more about them in the next slide. So here are images of our data sets. For example, as I said earlier, there is redness, there is lumps, then there is malignant, and there is benign under microscope. Then for our pre-processing techniques for our language data set, we have to use filtering, normalization, tokenization, and noise removal. This is basically storing the data for processing. In case there is missing data, there is wrong data, relevant data, we shall use this to actually make the data uniform and standard. Then also for our image data sets, we have to use noise reduction and so many other algorithms are seen in this slide, like the Clahe for contrast enhancement. Then for our image pre-processing and classification models, we have to use pre-processing pipeline for the images, that is Clahe, and Clahe for contrast enhancement, and HGLCM for feature extraction for the relevant features for our dataset. Then we shall use a darknet 53 CNN model, which is deep, reliable and efficient, since it will produce reliable results because of its depth and its reliability to actually give out sensible output that's correct. Then for our RAG and language components, so this is basically a retrieval-augmented generation system. We're going to use the World Health Organization guidelines as well as the clinical guidelines. So in case someone is to ask the system, it will retrieve this data from the clinical guidelines, send it to the language model, and the output will be a reliable clinical information that's supported medically. Then for our evaluation metrics and testing, we have to use both technical metrics and human evaluation. For example, accuracy, precision, recall, F1 score. For the human evaluation, we have to use clinician user acceptance testing, whereby an person will use the system and actually tell us if it's wrong or if it's accurate. Then we can also use different tribes to actually tell us if the system actually gives us the accurate language support for the multilingual system. Thank you very much. That's where our slide ends.